Hi, this is Shirley Physics, episode on the center of mass, or finding the center of mass of objects. A great situation is a couple of kids on a seesaw, right? Is the fulcrum exactly where the center of mass is? Usually it's not. So I'm going to take away that fulcrum, and we're just going to try to find the C of M, the center of mass for this board. But first off, for the board itself, we should consider that it might have a mass, and if it's a seesaw, it could be rather massy. So I'm going to say about 50 kilograms for that seesaw. And I put a 40 kilogram kid out here. We'll call this mass 1, mass 2 is 40 kilograms. And we put a 80 kilogram adult over here. How well is that going to work out for balancing this system? All right, so the question is, where should we put our fulcrum so that we get a balance? Should we put it closer to the kid? Should we put it closer to the adult? And whenever you're doing this, you need to start with a location. Any arbitrary location works. It could be the center of the object that you're looking at. It could be the center of the seesaw. It could be on the end. I prefer underneath or over top of one of those because, as you're going to see here, it just makes the math a little easier. So we put like some arbitrary spot here, that'd be fine. But it would just involve a little bit more math, as you're going to see. Now, one last important piece here is we need a length or a distance. How far apart are these things separated by? So let's go ahead and say this seesaw is a length of 4 meters. And now we have some perspective here. Now, big question is the seesaw is a 50 kilogram mass. So where would its center of mass be for the seesaw as an object? Well, for each of these people, we take their center of mass being the center of their being. But what about the seesaw? As long as this is a uniformly mass distributed seesaw or board, as long as it's of uniform density, then that center of mass for the board is directly in the middle. And that's important to know as we move along here. So how do we find the center of mass? It's actually a weighted average to find the position of the center of mass from our reference point. Now in this I'll get to the reference point in a minute. So to find that XCM, the position of the center of mass, we're going to take the mass of the first object times the distance, the position of its center of mass from our reference point, plus M2x2, mass 2 times its position, plus M3x3. Now, if there are more than 3 objects, we would keep on adding them. M times x plus M times x, and so on. And we're going to divide that by the sum of all the masses. So that's why it's called a weighted average. Notice it's a sum divided by a total. Kind of like a total number here, but the total number is we're dividing out all the masses, and we'll be left with just positions. Now it might look like, isn't that just going to divide all the m1s out and we'll just have x1 plus x2 plus x3? Not with fraction math. This is going to be taking this term, dividing it by the sum of all the masses, this term divided by the sum of all the masses. So it is a little bit different. In general, we might write the sum of all the mx's, little I there, divided by the sum of all the m's, little I. And each of these are the little i's going there. So that's it. That's the formula in itself. Hopefully it'll be straightforward for us. So to find our center of mass, as long as it's like the x direction here, that's why I have an x there. What we need to do is figure out a origin point. I'm going to take it from right here, underneath this 80 kilogram adult. As you can see, it's going to make the math a little bit easier. So first off, we're going to take M1, which is, I have marked here as the board. So the mass of the board is 50 times x. Now the distance from my origin here to the center mass of the board is half the length of the board, 2 meters. So we're going to take 50 times 2 plus mass 2 is the kid, 40, and the kid is 4 meters away from my point here, and plus the mass of the adult, which is 80, And here's where I say it's going to make it a little easier because that adult is 0 distance away from that position, that origin point. Divide all that by, trying to move everything into perspective here, divided by the total mass. So this would be 50 plus 40 plus 80. It's total mass of the system. And we work that out. We got 100. 50 times 2 is 100. Plus 160. 4 times 40 plus 0. And divide that by the sum. It's 90 plus 80, or 170. So we get a position 260 divided by 170. And we're 1.53. So 1.53 meters is an x we got, and this is where we go back to our original origin. So that'd be 1.53 meters from here. So this takes us somewhere about right there. That's where we should put our fulcrum. 1.53 meters away. And hopefully that makes sense. If you're ever trying to balance a system like this, put the fulcrum closer to the heavier object. We do have the center mass of the board to the left of that, along with the child. Now, what if we've got something like a two-dimensional, like a really strange-looking object? I'm going to take an arbitrary length L. And do something funny with this. Trying to keep all these lengths kind of standard. And yeah, it looks a little crooked, and you might get that at times. Just our axes that we choose are kind of arbitrary, and we can choose whatever we want for them. And I'll make this little segment an L over 2, where the rest of these are little lengths, capital L. Okay, so here's a piece of our object. Here's a piece. Here's a big long piece there. And there's an extra long piece and a short piece, length L over L halves. In this case, to find the center mass of this object, we need to look in 2 dimensions, the x and the y. So we're going to find both an xcm and a ycm. Mr. Shelley, why? Because we need to find the ycm. I'm going to take the x this way and the y this way. I will start with a origin position right here, and go ahead and do that. So everything that we measure in the x and the y direction will be from that point. So each one of these segments L has a mass little m. That's what I'm going to just say here, whatever that might be. Okay, let's see what happens. So in the x direction, we've got 1, 2, 3, 4, 5 pieces that we're going to be putting together here. Ooh, I might need a little bit more room on my screen. Let's see. So for this first piece, its center of mass of that little tiny piece there is half a length away. So for this piece right here, its center mass is right there. It's half a length away from my origin in the x direction. So that little m is going to be L halves. Yes, this gets a little tedious. I'll make that a little bit bigger for the viewing audience. L halves. And this next little piece, this little m, is 0 distance away from my origin in the x direction. So this little piece is right over top of that origin. So we're not going to add its length there. Now I can look at this whole length, this whole piece here. It is of mass 2m. So there's 2 lengths of it, so I can call it 2m. And the middle of it is a distance L away from the origin. And now we've got this length here. There's 3 L's. So there's mass of 3m. And how far is its center of mass here away in the x direction from my purple origin there? It's a length 2L. And sure enough, I'm going to run out of room here. And finally, for that last little tiny piece, just to make it interesting, this is a half mass, And what's the distance? Well, let's see. If that is half an L, then our distance to the center of mass of that little piece, just to be ornery, is 2L plus a quarter. 1L plus 3/4. So 1 3/4 L. Let's see, 1 3/4, that's 4, 5, 6, 7/4 L. There it is. So 7/4 L is our last little piece there. Oh my goodness. And what's the total mass of this whole thing? We got 1, 2, 3, 4, 5, 6, 7.5. So divided by 7.5 m. Oh my word, what is all this? Okay, so we're going to have an m plus m plus m plus m. All these m's are going to cancel. So each of those terms is divided by m. That makes it a little easier. And we have an L in each of these terms, so we're going to have an L times so we're going to get like a fraction of L. All right, we got a 1/2 is one of those terms, plus 0 plus 2 plus 3 times 2 is 6, and plus half of 7/4 is 7/8. Okay, so we could do a bunch of fraction math. You can't forget dividing it by 7.5. But it looks like we're going to get a decimal in the end anyway with that 7.5. So I'm going to go ahead and work that together for the greater good. So 0.5 is 1/2, plus 2 plus 6 is 8, plus 7/8. That gives me 9.375. We're going to divide that by 7.5. Much nicer looking than fractions. And we get 1 1/4. 1.25 L. So from this point, our x direction is 1 1/4 L. Here's 1 1/4 L would be about right there. There's our x position of the center of mass. Next, what about y? This one might be a little cleaner. We'll find out. For our y position, this little piece L, now we're looking at a y distance away. It has mass m, and it's a distance L away from our starting point. So we've got an ml. Don't need that parentheses. Plus, we've got this little L. That's another mass m, but its center mass is only half L away. And the center mass is right there. Half L away in the y direction from our purple spot. This little bar here, it's of mass 2m. However, it is 0 distance in the y direction away from our origin. And then we got this long one here. It's of mass 3m. In the center of it, its y direction center is L plus 1/2. So 3/2 L is that distance, 1.5. And this little piece up here, this little half m, its center of mass is right here, but it is a distance 3L away. And divide all that by the total mass, which is again going to be 7.5 m. All right, so we get our y position. M's cancel out from every term with this one. And we get a L times, here's a 1, can't forget that 1, plus 1/2, plus 0 from this term. And here we have a 3 times 3/2, it's 6/2, or, I'm sorry, that'd be 9/2 L. So that term is 9/2, and then we have a 3/2 over here. All divided by 7.5. 2/2 plus 1/2 is 3, 12, 15/2. Divided by, interesting. 7.5 is half of 15. Okay, so that makes it a little easy. This is 1L away. So our center of mass in the x direction is 1L away. So here is the center of mass of the system, located 1L up from that purple origin and 1¼ L to the right of that origin. And that's the find the center mass. Hopefully that second one helps you do some of the harder problems. And of course, I'm always here to help. I hope this was helpful.